Hello, everybody. Welcome to Vegas Programmers. And first of all, thank you for somehow making it here through the flooding. And yeah, so I had to dodge a couple of puddles that I thought it was, I'm like, oh, black ice. It's not that cold. I don't know why I'm saying. But thank you to Adam Englander here, who's going to be presenting Agentic Applications. So this talk is to demystify AI agents. It goes into a lot more detail. I always love Adam's talks because they not only kind of give you the high level, but also he digs really into details. And so thank you very much for doing the talk this month. A couple of announcements before we kick things off. First off, I printed way too many of these stickers. It says PHP is not a crime, because it's not. I know people give crap to PHP, but please take one, even if you hate PHP. It could be in double entendre if you want. And so also shout out to corporate co-working. They are awesome. Without them, we wouldn't have a space to do this. In fact, finding a venue right now is actually extremely difficult. So shout out to them. They don't charge us a nickel. If you're looking for like co-working space, this place is a spot. In fact, for a limited time, they've also just opened up month-to-month private offices, which I've been thinking about myself, because my dog is more annoying than my kids at home. But let's see. And then also another thing about next month's meetup, just given the holidays are so close to when the third Tuesday would be, I'm going to be moving it to December 3rd. Reason is two reasons. One, AWS reInvent is in town, so there's going to be a lot of developers and things like that coming through. Plus, we also have a special guest speaker from Apple coming down to talk about Swift, and perhaps another guest I'm trying to pull from the AWS kind of speaker pool. So stay tuned for that. Just don't show up here on the third Tuesday next month and wonder where I'm at. And obviously, the venue is really accommodating to kind of switch around dates for that. That's it. Let's kick it off. So without further ado, Adam.
Cool. Thanks. There's at least one person who's heard this talk before, although they didn't see it. I gave it at the Python group when we didn't have anything to present on, so you at least get to see stuff now. So I'm Adam Englander. I'm the CTO of Voltaire, which is an AI company building tools for insurance companies. I actually started in AI looking at agentic stuff, right? When we first started coming in, we didn't know what we were going to do. We were just going to do something in AI. We were a lab at that time. So, and agentic was something that really was kind of taking hold. Unfortunately, the LLMs at the time really couldn't do very well with it. Their context was very limited, so it was difficult to keep context as you're moving through stuff and doing anything complicated. But today, everything is agentic, and I don't know if everybody even understands what agentic means. Most of the people I talk to don't. And the reason they're talking about it is kind of the real power of agentic AI, right? And it's something that we've been moving our application towards, although it's little kind of baby steps. Just the amount of information you have to do. Like we write applications that parse insurance policies and find out why things that you've tried to claim on your policy aren't covered. And policies are hundreds of pages long of text, which is a lot of context. So there's the desire to make it agentic is great, although between the amount of size of the context that we have and the amount of time that it takes to process, putting inside of agentic is going to make it slower, and that's not going to make our customers happy right now. But as the models get faster, it makes things like that easier. So like one of the powers, the promise of agentic AI, right, is low-code applications. So you dynamically consume services, let the model handle the logic, right? You give the model the idea of like, here's your parameters, here's the things you can do, and then it'll figure out what it has to do as opposed to you writing a bunch of branching statements, right? If the input is this, then do that. If the input is that, then do this. And if I get this back, right, you create this whole flow and a workflow and all that kind of mess that you write a lot of code for. So there's advantages to low-code applications as long as it actually works well. And in theory, they could be self-correcting and improving, right? Every version, I'd say every 6 months, there's the latest and greatest, right? Like we just got 5.1 for OpenAI and 3 for Gemini, which are like, I wouldn't say they're not like a massive leap, but it's a big step forward from what they were. Definitely Gemini 3 is so much better than 2.5. So as the models get better, your application gets better and you don't have to do anything. That's actually kind of nice. Zero code upgrades. So if you want to upgrade services, if you're consuming services through an agentic AI, one of the nice things about using dynamic services, and we'll get into what MCP is in a minute, but as the definition of the external service changes and its abilities change, the model automatically knows this, and you don't have to write new code, right? So it's like one of the worst things that ever happens is you're consuming an API that does something that's not backwards compatible, right? Or they've released this great new feature, like great, now I've got a code for more stuff on the API. The beauty of agentic AI, right, is that the model is the one that says, oh, this service now has these things available to it, I can just use it. Although, you know, it's questionable how well it can use it by itself without knowing what it's supposed to do. And again, no backwards compatibility because you don't break the AI because you didn't code for it, right? It's not hard coded to say that, oh, I'm going to pass it this attribute, but that attribute's not there anymore. So instead of pinning to a version, you can always be on latest, in theory. Your mileage may vary. Again, self-improving applications make the model better. Without coding the application, the models themselves can get better. And then again, the application improves with the tools. So if you're consuming external tools through MCP services, if the tools get better, your application gets better, right? If they're like, oh wow, it doesn't handle this one thing well, but now they've got a function available to it that it can do that better, it'll just magically be better. So that's really nice. But there's fine print, right? Having the model manage this is a lot of latency, right? Code is very fast in theory, right? Fast is relative, but you know, bad code can process things in half a second, right? And models, not so much, right? That's pretty quick coming back on just thinking about what it's supposed to do in half a second as opposed to actually doing anything. Cost drift. So the AI may go back and forth, and depending if your APIs cost money and how much your model costs, right? To have it do something, it could have to think about it and ask questions and think about it and ask questions and think about it and ask questions, right? Every time it does that, it costs you more money. Non-determinism. So the big thing about AI is non-deterministic. You ask it the same question twice, and it may not give you the same answer. So if you're writing applications, you're very used to 1 + 1 = 2, right? Where with an AI, 1 + 1 could be a mathematical equation as opposed to 2. Depends on how it's feeling that day. Prompt brittleness. So the way that you tell a model what to do is you send it a prompt. And if your prompt isn't well written, it can have problems. If you write a prompt, we talked about the automatic upgrades of being able to, if there's new services available, if your prompt is very specific about what happens in the steps, it may not be able to use the new availability. And if it needs something that's not there anymore, right, that the MCP server doesn't serve you anymore, then it's just going to break because it doesn't know what to do. And in my experience, when models don't know what to do, they just kind of make it up and do whatever they want, which isn't great. And then there's tool failure surfaces, right? So if the external tools are failing, your application is failing. And yeah.
The point about the hallucination,
Yeah.
does it help when you tell the prompt, like, please be honest and it's okay to fail, sort of thing?
It depends on the model. They're getting better at that. Models are getting way better at, I don't have an answer, especially if you tell it that I don't have an answer is an answer. But the earlier models, I would say, like if you think about OpenAI pre-5 or Anthropic a year ago, and I haven't even really messed with Gemini back there, so it wasn't very useful. But they were like, their whole reason for being is to be a chatbot. A chatbot has to have an answer, right? So it's going to try and come up with an answer. They're working to get it to lets you know when it doesn't know. But what you can do to make it not do that is just something you're going to have to figure out model by model. It's one of the things that, like, prompts are not, well, most prompts, if you're doing something complicated, the prompt is not transferable from model to model because they all act different ways, especially if you have a fairly complicated prompt. And so, like, on my particular case, that's a serious problem for us because we're like, oh, I need you to tell me, find me, like the insurance adjuster says that this item, right, the roof is denied because it's wear and tear, not from an accident or an incident. And if it can't find a way to justify that it's there, it'll pull pieces out of different pieces of policy to make it look like there's a justification. Like, so it finds a way to make the answer, right? If you're coding using AI, it will change the definition of done, right? Like, all the tests passed because I made the one skip that didn't work, right? But all the tests passed. That was my problem today. That's one of the reasons I got here a little bit later than normal, is I was really angry with AI. So yeah, getting it to fail gracefully is difficult. But it is something you can do. And please, as I'm talking, if there's something that you have a question about, interrupt me, because you probably won't remember at the end, and it means that I probably didn't explain something well enough. So don't feel bad about asking at any point. So let's get into how agentic AI works. So most of your applications, right, you have core logic. In agentic API, you also have agents, right? So agents are, they could be local, they could be remote, right? There's some sort of code that's going to do something outside of the model that's exposed to the model, right? Models can't do anything, right? If you, like, ChatGPT makes you think like a model can, it's actually an application using agents with a model. And so agents are things that either retrieve data or do things for you, right? They'll get things or they'll do things. There's an LLM, right? So an agentic AI application has AI at its core, and that is really important. And you may or may not store state in between interactions, right? Depending on the complexity and like if you, right, let's talk about writing code, right? If you're using AI writing code, you'll find, oh, it creates a to-do list. But if it doesn't put the to-do list in a file, it will get past a certain point where that gets out of its context and forgot what it's supposed to do. So if you're doing large things like I do, you create a giant feature, you want it to create a file, which is its state. So it knows that, oh, here's what I'm supposed to do, and here's what I've done already. So when it comes back and it's done a bunch of really complicated things, you're like, okay, now continue. And it's like, oh yeah, I'm here. It's the same thing with any application. You may need to have state to know, to get proper context on, you're responding most of the time when you're doing agentic stuff, you see a lot of it with chatbots, right? And so the history of the conversation is important because you can say, yes, do it, but if it doesn't know what it is, it's not very helpful. So that's either local state or if it's, in some of the stuff that we're doing, right, we store the state of the letter in process because it takes a while and adjusters do other things. They get a phone call, they've got to go away from what they're doing, they've got to come back, right? So we store the state so that the model can continue and they can pick up where they left off. But again, at their core, agentic applications are applications, right? And it's a bunch of code. There's nothing super, like, it seems mysterious, but it's not, and we'll get into, like, if you use the libraries to just make it happen, it's very mysterious. But we'll go into some examples where how you used to have to do it before MCP servers and lane chain. So, yeah.
So for that state, is that like the same thing as quote-unquote memory for the agents, or is that something completely different?
It can be memory for the agents. It depends on what your application wants to do, right? So if there's things that are important to processing, you may want to hold that information somewhere so that you can keep feeding it back. It depends on the length of what it's doing, right? So it could be as little as just like it's something in the session that you keep moving back and forth, right? That you know that this is the user, so to get information about the user, it has to know which user it is, and the state's stored in the session. If it's via an API, there's no way to know that, right? So either they're passing context to you, or you're having to store it somewhere as part of a transaction, right? So I'm going to go do this and this and this, right? Because at times, like we have complicated stuff that takes 7 or 8 steps, right? And so it's got to move the information between the different models. And for us, we can hold on to the state because it's a single action that's going. So it's not that big a deal. Like if you're writing code and it's a long thing, right? You have to be able to manage the fact that it's going to run out of memory. It can't pass the entire context. So if it's going out, I've got the list of directories, I got the list of the files, and I opened up all the files, and I looked inside the files, right? You can't have all of that data every time it goes. But there are certain things that might be important. So it might hold on to that. And again, the state could be inside the application. It could be something external if you need to resume, right? It's just something holding information that's important to the process. No problem. And so agentic applications tend to work in this kind of 5 section process. And if you've used any coding tools, right, you'll see it doing this stuff, right? It creates a plan, it does an act, it observes what happened from the action, it reflects on what it observed, then it makes a decision about what it's going to do, and then it may have another plan, right? So if you tell your IDE or like Claude or whatever it might be, here's the feature, go do it, right? It's going to say, oh, I need to plan this. I need to figure out what this means. It's going to look at files and find out what you've done before, right? It'll act, which is go look at the files, observe what's in the files, reflect, well, how are these files similar? What am I going to do about those files? And then it makes another plan, right? So it's constantly just going through this process of getting information, sending it off to agents to do things, getting the data back, seeing what they did, figuring out what they did, what does it need to do next, and then start the plan all over again, which is basically just told you to do. Kind of went through it here. But yeah, creates the plan, act, solves. I went through all that. So if you take like an agentic example, does anybody have any questions about that really quick? Because I went through it pretty fast. Okay. So if we look at agentic application, right, so let's close issues open for more than 30 days with no activity. This is something that we have a cron job that runs right now for the Palettes projects. It's a Python organization that does like Flask and Jinja and some other tools, Court. But that's something we have to do. And every time that there's an upgrade or a change to the GitHub actions that we're consuming, we've got to make changes to our stuff. It's kind of a pain. If we add a new project, we've got to then put it in there as well. It'd be really nice if we could just have it living somewhere and have this AI to do it. So it all starts, right, just like everything in AI is with a system prompt, right? So the system prompt is, and again, this probably doesn't work. This is just an example, so don't copy this down. But again, like what I do and what we do in my company is very similar to this stuff, right? You've got a system prompt that gives it parameters, right? Use the available tools, so it's going to have information about tools. To identify all open issues in a user-provided repo. So that means it's going to get the repo in a user prompt. That has not had a comment added for the last 30 days. Close each of the identified issues and add a comment saying it was closed for 30 days of inactivity. Right? This is a gigantic GitHub action that we kind of share in our project amongst everything. It's really big. To do all of that in using functions and GitHub actions, it's a lot. Especially since not all of the, sometimes we have repositories in our ecosystem project that we didn't create it, so it might not be in the exact same setup and it might have different stuff in it. It can get really crazy. And then there's the user prompt, right? Close all inactive issues in the group repo repository. So that's it. I told it that there was going to be an organization and a repo it's going to go look in. Then there's a GitHub MCP agent. There actually is a GitHub MCP agent, and these are actual functions in the MCP agent, right? So list issues, and state is the internal state that you can identify for the things, and since, right? So list issues that have this state since this date, which is super helpful because we want to find all the open issues that are more than 30 days old. And then you can get the issue because the details about the issue you can't get from the list issues. We want to update the issue because you want to close it, and you want to add a comment. right? So these are the methods. There are dozens and dozens of methods available in the MCP server, but this is what's there, right? So the AI goes through its plan, right? It says, okay, well, first thing I'm going to do is I'm going to get a list of open issues for the last 30 days. I'm going to identify issues from the list with no comments for 30 days. And then for each stale issue, I'm going to add a comment, closing an activity, and then I'm going to update the issue to close status, right? It'll then act. So it tells the AI is going to tell you to tell the MCP server to list the issues for the repo with the status of open. Right? It'll get the response back, so you ship that back to the LLM, and the LLM says, okay, there's 0 records, right? There's nothing for it to do. It reflects and says, hey, there's nothing to do, and it decides not to do anything. Right? This is the very simplest example. If there were actual records, then it would have gone through multiple plans. Right? Okay, well, here's the records I need. Let me go get through each one of them and get their information and see if I'm supposed to close them or not. And that's basically the process as you would go through for something like that. Any questions? Okay. Model context protocol. So this is a standard way of designing and exposing agents. So MCP is an open protocol, right? So it's available for input and expansion, although it was created by Anthropic. They're calling it open. I haven't heard anybody complain about how open it is yet, because most people just kind of use it the way that it is. So it's an open protocol using JSON RPC2 messages. So it's a protocol built on another protocol. It has a life cycle. Initialize, negotiate capabilities, operate, shut down, right? So you initialize the MCP server. When you connect to it, you negotiate capabilities, and then it just does what it does, and then it shuts itself down. So server features, there are tools and resources and prompts. For the client feature, there's sampling for server-initiated model interactions. And then there's transports. So SSE is legacy, so I wouldn't do it, but they have standard I/O and streamable HTTP. So if it's external, right, if it's remote, it's streamable HTTP. You'll just get a URL that you'll open up your MCP server against, and it will go query that and get all the information. The ones that I tend to use are local through standard I/O. Simpler on some programming languages than others. Right? A lot of this stuff is written in Python, which is my primary language, and opening up other processes and being able to communicate with them is just a piece of cake. You can do it in PHP. I've done it in PHP. It's not as pleasant. Although they just did announce something that that somebody's paying a bunch of money to make that better. They're getting a grant from Germany to make that better. And there's a rapidly growing list of services exposing MCP servers. Everyone has their own opinion, but the world seems to be going towards, there was a day when everything needed an API. It needed a REST API, right? Some had SOAP services, because that was the promise of the future in like the late 90s, early 2000s. And then REST APIs were everything for quite some time, and now REST is dead. Everything's run by LLMs. If it's not an MCP server, if you don't have a way to access your whatever you do via an MCP server, you'll be left behind because AI is going to do all the work, which is entirely possible. So there's a lot of people who are companies and services that had applications. They now have MCP servers. Like the 3 things that I get the most use out of is there's an MCP server to go use the AWS documentation. There's one to actually interact with AWS, and one that has their to be able to create graphs from information in there. Because if you want to go find out what's going on in your system, you either already have something built, or you've got to go, oh, I got to go to this screen and look at this, and then I go look at that screen and look at that. Because, oh yes, there's something going on. Here's my my firewall, and then here's the firewall settings and what's getting denied there, and then here's my application load balancer, and here's the logs from the app, and here's Kubernetes, and here's everything is everywhere. Or you could just tell a model, hey, I want to find out this information. It goes in and looks it can query what you've got, and then go look at it. which is really, really nice, especially if you're doing, I do a lot of development of infrastructure as code. And so it can go look at like, okay, I need to do this. So it goes and actually figures out what I actually have. Then it looks at the documentation, because sometimes the documentation for Terraform modules aren't that great. It's like, yes, you put in the attributes. It has no idea what the attributes are, so it's got to look at the documentation. So it's been really helpful for me. But there are MCP servers for almost anything. So where MCP fits in the cycle. So it's got its fingers in all parts of the cycle, because the LLM decides whether to use a tool, but it needs to know the tool exists. And the exposure of the tool is what MCP does as well. Act is that it's telling your application to call the tool from the MCP server. It observes the structured results, because again, the definition of the tool tells you what results you're going to get back, so it knows what it's looking at, and describes what all the attributes that it gets back are. Then it reflects, so it'll likely, or it may decide to make more tool calls. So it lives in like 4 out of 5 a lot of the time. So in the MCP lifecycle, there's a lot of JSON. Hopefully it's readable. Because, again, it's JSON RPC. So if you're familiar with JSON RPC, this will look very normal. If you've done if you've just got it, before this I was in crypto, this looks very familiar because interacting with any sort of crypto agency is JSON RPC. And so basically the client tells the server to initialize. So it's basically trying to figure out what do you have, what can you do? And so it calls the initialization, and it's going to give it information back about it. Then it does a negotiation, right? Trying to see, like, hey, did anything change? Give me the tools. I want the prompts. I want the resources. You can tell it if it's changed or not. So only do this if it's changed since the last time. And the information about the last time is based on the ID. And then the server gives the client server info. Then it'll request a list of tools, right? So it's going to say, hey, give me all the tools. And then it responds back with, here's the tools. So in the example that I did today was like, one of the MCP functions is add 2 integers. And so there is a tool whose name is sum. The description is add 2 integers. The input schema is of type object, and its properties are A and B, which are both integers, and they're both required. So it's describing, here is a tool that you can use. Here is the information that you'll provide it. Here are the types that they are. So that a good LLM will know to be able to do that. Most LLMs today are trained on this protocol, so they understand this very well. Invoke the tool's request, so it says, great, the LLM wants to add 2 and 3, so it makes the call, so the method is tool's call. The name is sum, because that's the tool, and the arguments are 2 and 3, 2 integers. It gets a response back. Result, content type equals text equals 5. Should have been an integer, but I did something wrong, I guess. Why would you want to return text from adding 2 numbers? And there is no error. So is error false? And that's basically all of the protocol. There's the transfer that you do it over, but beyond that, it's all just a bunch of JSON going back and forth. Any questions about that? I know that was like super deep and probably unnecessary. Yeah?
Just to kind of demystify what we were talking about, REST is dead. So I was under the impression that within an MCP server, you would be writing API calls to go do things, and that in the MCP, it would basically be using API calls to go do that, but giving you an MCP context to go do these things. So I just wanted to clarify, like, is that true? Like, MCPs have to be server-side? So, like, for example, the get one that you did, does that actually have to live on get servers in order for them to actually go do things for you, to actually have it go write instead of just read, I guess? Like.
So actually, I was running it local, but they also do have one on their servers. So what I would say to you is that likely what's happening today is that people are just putting MCP in front of their APIs, but that's not going to be optimal, right? It's like when people move from SOAP servers to REST servers and it just looked like a SOAP call instead of actually a representational state, right? It didn't, it wasn't set up as, entity, ID, attribute, right? Like it wasn't set up like actual REST. And then people found that REST was kind of annoying because it's just a really bad representation of a database. One of the things that ends up happening is a good MCP server is going to be able to return only the information that is necessary. So it's almost like you're more likely to kind of wrap a graph database around it, right? Because you want to select only the pieces that it needs, because if you return it back a bunch of junk, you're just going to suck up all the context and it's not going to be able to do anything. So good MCP servers are going to provide you ways to filter down to just what you need, so you get the information that you need and nothing else. And it all comes together at one time, so that you don't have to go back and forth with LLM calls of like, oh, cool, I've got an organization, cool, now I've got that. Now I need to get the users, get a list of users, cool, I've got a list of users. Now I need to go get each one of the users, right? That's a round trip every single time, right? Where it's like, get users with details. It could just return the user information, and then you could maybe, tell like, here are the attributes that I want to be able to select, and just return the ones that you want, right? So because of how much time it takes, so latency and the amount of data returning from context matter, right? Because when you're consuming a REST API, it doesn't really matter. Yeah, there's some expense of it moving across the internet, but that's usually fairly quick. And the stuff you don't want, you just throw away. Because you've written an application that's very specific, saying, I'm just going to look at these things that I care about. I get this giant object. I might not even parse those pieces. I'm just going to take a look at the pieces that I want and throw the rest away. The memory doesn't really mean anything to me. Where in the context of an AI, where you're holding on to that information and you keep holding on to it because you need some critical information, you're either going to be stripping it in the MCP server itself, right? And so you may be making 6 calls to get all the data, which, again, even if you're really close, that's like 300 milliseconds. If you make 6 50-millisecond calls, that's really fast. Or if you can just get all the data at once. So I agree that, yes, I'm assuming that it's very easy to just wrap an API, and there's got to be tools that are coming out, right? They're just like, give us your OpenAPI JSON and we'll create a server for you, and it just magically happens. I'm waiting for that one. But that doesn't mean it's going to be good. So I'd say a lot of services that are out there, there are 2 ways that they can distinguish themselves, is through ease of use and how good their API is, right? Like I know when I worked at one company, it was XML, but we actually consumed another company's services, and there were people that consumed it directly and moved to us to pay us more because we gave them back better data. It's that we consumed the same data that they did, but we just put it in a way that made sense, that you could actually consume and not write a bunch of code. So people are willing to pay us more money to be in the middle of that same call because the data was better. So that's one way that you can distinguish yourself of like having a really good API. And I'm assuming it's going to be the same thing with MCP servers. Yeah.
Does the ID change with
Yes.
the response and
The ID is the identifier for the call. So yes, it changes every call. Yeah, just coming back as a stream. So you could have set off question 1, question 2. It could give you back answer 2, answer 1. So yeah, it's going to have an ID because it's just streaming stuff back and forth.
Okay, at first I thought the ID was for like the actual MCP.
No.
That's what I was confused. So I changed.
Yeah. The ID is for what you're doing, it's arbitrary, but you need to have an identifier, unique identifier. If you're sending request 1 and just getting back answer 1, it doesn't really matter what it is. But if you're, because again, this is streaming HTTP, so you could send question 1, question 2, question 3, and get back answer 2, answer 3, answer 1. You've got to have a way to match up the question with the answer. So if you've got something that's kind of in the middle, and you're processing multiple requests through one LLM, and you're just kind of doing it all at the same time, asynchronously. It's important. If you're doing it synchronously, it doesn't really matter. It's only going to give you back. You're going to send one question and get one answer, send one question and get one answer. Hope that helps. So there's MCP library. And what's available besides Python, I have no idea. I'm sure somebody's coming up with them. Anthropic came up with the specification. They also came up with a server inside the library called MCP in Python. They probably did it in JavaScript, but I don't know. A lot of the stuff in AI goes Python first, JavaScript next, and then they figure out the rest later. And so this is an MCP server to add two integers, right? In Python, it's just as easy because Python has decorators. Not as easy in other languages. But basically, you just have a function, adds things together, and it comes out. And this is, we actually have an example that does something similar to this. And again, the MCP server has an identifier, and the identifier is the agents talk demo MCP server. MCP client is fairly almost the same, right? Where you create a client. This is a standard I/O client, and you basically say, hey, server, here's the command to run, here's the arguments to run against it, and then launch another process and just send standard in back and forth. And again, this can also be asynchronous, where you send it multiple things, question 1, question 2, question 3, and it can come back in not the same order. Just depends on when the server gets the response back, and if the server is asynchronous. But basically, yeah, you just create the server, and then you get the client with the params, and then you've got read and write. So that's the input and the output for the standard I/O. You create a client session, you're giving it the read and write. Session initialize, which is the initialize protocol we talked about. List the tools, and then call the tools. So there's like, it maps up really well to the protocol, but like, there's a lot of stuff there you just don't need to understand how it works. It doesn't really matter. And so that's using the client. And there's an even easier way if you write Python. And it's called LangChain. It is the library for AI. It has been for a while. There are some competitors coming after it, but if you go to any AI conference or any Python conference, they tend to be talking about the LangChain library. Because it does all the things other libraries do and kind of puts it all together. And this is how you would actually create it for, this one's for GitHub. So this is a remote one. So you've got a multi-server MCP client. We're only giving it one server right now, but it could have multiple. And you're saying transport is streamable HTTP. Here's your URL, and your authorization header is a GitHub token for doing as a bearer token for OAuth. And then you get a client with the session GitHub. There's your client. It loads the tools, creates an agent, and then invokes the agent. So basically what this does is this creates everything inside of it, right? So LangChain, oh yeah, sorry, it's way down there. LangChain puts everything together. So if you were to, there's a, like when we talked about it, there's ways to do this. So you can start off here. You can make JSON calls, right? And you can go, get this tools list. You'll get this back, and you'll tell your LLM, here are the tools that you can call and what they do. And then it'll tell you to do stuff, and you'll have to parse it to see what it said and kind of go back there. Or you can even just not use this, right? You can just tell an LLM, which is how we're doing it early on, is like, here are the things you can do. You can do this, and you're going to pass me, you're going to give me this and this, and I'll give you that back, right? Some way to describe what it's going to call, what it's going to receive. You can get, MCP allows you to get that programmatically, and then the tools allow you to, so with this one, right, this is the server, there's the client. You're going to have to talk to an LLM, right? That's the part that's not in here. This is how you talk to the tools. But you're going to have to tell an LLM, hey, I've got these tools. And then you're going to have to get a response back and know how to parse the response to saying that it asked to use the tools. And then you're going to have to execute the tools, and then you're going to have to put it in a way that the AI will understand it and respond back to the AI so it can continue with what it's doing. LangChain does all of that in like 20 lines. So it will handle, now there's a lot of magic. There's a downside to it, right? There's magic. There's a lot of stuff that we had LangChain do early on that we broke out because they do it a particular way to make it easy, and it didn't work super well for us. My understanding is that now you can kind of make those adjustments. They've kind of separated things out more and made it less magical and more configurable. But we just haven't had the time to go dig into the new functionality and figure it out, so we still have it all separated out. But again, it is super easy to just, like, as long as you do this, and I've got examples where you can see it just going through a loop, and it'll just process all the things you want to process. So any questions before we get to example code? Okay. So let's get to example code, which means I need to now mirror and remember how to tell this stupid thing to mirror. There it is. Stop extending. And what's a mirror? Come on. Choose content. Let's do the entire screen. All right. So I have a project here. I just finished putting it up on GitHub. And it's not showing that. What's it showing? There we go. Now let's see what it does. All right. And I will go into display mode. Oh, one of the things I love about Claude is that I can use this again. Where's presentation about? Oh, top. It's been a while. Of course, I got the wrong one. I don't want that. Of course, open the wrong file, and I never remember what the damn command is to open another file. Let's quit. It's all right. There we go.
Yeah, if you do view.
I'll put the bar in.
Yeah.
Tool Windows project. All right. Right. And so this is Python. If you're not Python, let me make it bigger if I can. Can't I? No. Can I make it bigger? Nope, nope, nope. Increase font size in all editors. There we go. And that is Control-Shift period. Is that readable? Okay. So this is Python, lots of importing, just like you're in most languages. And so I put the functionality for, so we have this shared tools thing that's just two functions, right? Add numbers, and then get time. So it'll return the current time in a very Python way. Although having this down here is not very Pythonic. Pretty simple. And then so example one, everything is manual. So I'm doing my own OpenAI client. I'm doing Pydantic models because OpenAI will allow you to describe things in Pydantic schemas. And all Pydantic is it's a schema library for doing validation, but it can also, it's easy to describe it. If you're doing things with OpenAPI, and most of the tools that are out there, the popular tools to do that in Python, you describe your input and output in, you can do it in standard objects, but if you do it inside of Pydantic models, it works a lot better. Plus, it can validate input and output before it goes. So if you're not familiar with Python or Pydantic, it's a validation tool that describes objects well, and so they allow you to give these models to the OpenAPI or the OpenAI client, and so it will properly turn things into JSON and it'll parse them properly, right? So you tell it, I'm expecting this type of thing back, and it will give you the data back the way you want it. It's one of the hardest things to do that for a long time, right? It's number one, to have it give you JSON, just JSON, not JSON with backticks, not JSON in quotes, actual proper JSON with things in the order that you want. That was always very difficult. And so Pydantic models are one of the ways they do that. So we're loading in the two functions. We do some load environment variable stuff. Here's some stuff for most of the code that's in here is to actually make it look pretty when you're actually running it. We determine if your TTY supports color, what level of verbosity we're going to use. Verbose print does stuff, right? And so we have a tool name class, which is an enum. So there are two tools. There's a tool call, which includes a tool name, right? So we're just describing these are the tools, and having a way to turn them back into something that we know, an enum. And its args are a dictionary, content, or assistant response. Content is always a string, and the number of, we're going to give you content, so I'm going to say something, possibly, and then I'm going to tell you what tool calls I'm getting back. So that's the expected assistant response. We have a system prompt. It says, you're a helpful assistant with access to tools. Respond using this JSON format. No comments, strict JSON only. For the text response, do it that way. For tool calls, do it this way. So we're in the system prompt, we are describing how we do this. If you change the tool, you got to go change the prompt. All right, kind of annoying. But we don't have any other way to do it. Here are the available tools. Add numbers is add two numbers together. Here are the parameters. Get time. You can call multiple tools in one response if needed. That's something that's very important to tell models that they can figure out all the things you want. Let me go get them and give them all back to you. Always include a content field that specifically describes what you're doing. Well, I should have made that shorter. With the given values, and return only valid JSON without any comments or extra text. And then we map the tool functions to the functions to the names. There's a function called getLLMResponse. So we give it conversation history. We get the API key. Probably should have done that way up higher. But blow up if you don't have an API key. Creates an OpenAPI client or OpenAI client. Creates the messages. So it's got the system prompt that you just saw. And then extends the conversation history with the messages that it has there. And then makes a chat completion with the messages and the model. It defaults to GPT-4o Mini, but you can specify something to get it as well. And then it returns the choices with the message context. There's parse response that goes in and loads the data and then creates an assistance response, which is going to validate it and make sure it came back correctly. And if it blows up, it returns an assistant response with just the content so that you can see what happened, because no matter how many times you tell it to give you back JSON, it doesn't always give you back JSON. Doesn't always give you back proper JSON. It might put a comma at the end of a list of things, and it really gets upset when you do stuff like that.
Does Pandemic or whatever take care of that for you then?
No, if you can't parse JSON, you can't parse JSON.
It just blows up.
Yeah. Yeah, 'cause as you see here, like when we're doing it, is we actually parse the JSON. Where'd it go? Yeah, I load the JSON. So if it's invalid JSON, doesn't matter.
Yeah.
And Pydantic, you're just giving it, basically this is turning, when you load JSON, it's going to turn it into a dictionary, hopefully, if it's got what we're looking for. And then it turns that into data. So this expands it into key value pairs setting to the function. It's a Python thing. Star and star star are super powerful in Python. They're freaking amazing. Right, execute the tool. So you give it a tool name and the arguments. So if it doesn't know what tool it's asking for, it just says, I don't know what you're talking about. Otherwise, it calls the function, gets the result, and returns it. And then main is where you're running things. Basically, it figures out what's your verbosity level, starts printing stuff, and then has this loop, right? So there's the cycle we talked about. It gets the user input, which is input users, how you get user input. It's actually pretty similar to PHP. It lowers it and says, well, did you tell me to quit or exit? If you did, I'm going to break. Otherwise, I'm going to create a new line, and then I'm going to append to the history a user interaction with the user input. So it's going to put whatever you typed in there into the history, and then again, it will try. And it's going to loop through LLM stuff until it doesn't have to do LLM stuff anymore. So it sends that request to the LLM. It will then parse the response to the LLM, add the LLM response to the history, so that when you send it back, it know what it said, because that's the only way LLMs know what they said, is you have to tell it that the LLM said this. We go through the tool calls, and if there are tool calls, then we process the tool calls. For each call in the tool calls, we go execute it, and then we print out what tool got used and what it did. And then we append the results to the tool results, and then we append the results to the conversation history. So now the next time when we send something back to the LLM, we're going to give the results, we're going to tell it what it said and the results of the tool, and then it just continues on. Right? It's going to go through that. Response content, and it just keeps looping. And so it's going to, again, a loop again, and it's going to send something to the LLM, right? So it just keeps going until it breaks. If there are no tool calls, it'll break out, right? So if it made a tool call, it gets the answer, sends it back to the LLM with what it said and what the tool said, comes back around, until the LLM doesn't ask it to do any more tool calls, which means it's done, now it's time to talk to the user. So it just loops through that and breaks out, right? That's an agentic application. That is a pain, but it works. If you wanted to use an MCP server to do that, right? We have an MCP server here. But I added these in here so they're all using the same functions, but basically, like we showed there, you're going to put a decorator around it so it knows, so the MCP knows that this is a tool, and it will register the tool, and it'll register that tool, and puts a bunch of magic in it, yay Python. And so now when I don't have to go describe all of the tools because they're described by the MCP server. So I can get the description from the MCP server, right? So I'm going to say, hey, I'm going to give you an MCP tool, or I'm going to give you the MCP tools, and I want you to, for each tool in the list, I want you just to return me back this dictionary, and I'll send that off to the LLM. Basically the same thing for get LLM response. It's doing basically the same thing, right? So it's going to return the message, and then in main, it goes and it spins up the server, right? So that's the MCP server Pi through Python. It creates a standard I/O client. So this is async I/O. Creates an async client with a session, initializes the session. So that's the life cycle of the MCP. And then tool result is session list tools. So it knows that. It gets to the format of it. And it does some debug logging for you so you know what's going on. And then it will run in an executor input. Oh yeah, so it goes and gets input from the user, extends that to the conversation, gets an LLM response, because it doesn't have any tools yet. It tells you what the tools are. Appends the response from the message. And then if there's tool calls in the message, it goes and does it through. So it takes a little of that out of the way for you. You don't have to describe and say, here's how I recognize it's a tool call. Here's how I'm manually putting in all the things that are available, right? So MCP takes a little bit of that away from you. Plus, if you have somebody else's MCP server, you don't write any code. But it's also super easy in Python, and maybe other languages too, I don't know. But it is super easy just to make a function and make it available as an MCP server, right? So if you're using some sort of desktop AI app, or if you're using some code app, right, and you're like, it does this wrong every time, well, you can just find a way to do it the right way and expose it as a tool, and that'll do it the right way all the time, right? If you're tired of, stop doing this like that's one of the complaints that I have, like stop looking at stuff 6 different ways and having me approve it because it's a different way that you've looked at it, and you didn't have quite that combination of commands together, and I don't let it just do whatever it wants. But I get stuck because I'm like doing something else. I come back, it's like, oh, you're waiting for another bash command that is slightly different than the last bash command, right? So I created an MCP server and I said, okay, do it this way now. And so it uses the tool, and it always does it the same way instead of coming up with the 16 different ways it can look for stuff inside of a file. So if you write Python, or you are thinking about writing Python, it is super easy to make an MCP server that you can just add to whatever AI application that you're using. That's really all it is to it. Create a function, do the stuff, and it does the rest. And then the LangChain example, right? I put a little more verbose stuff in there, but basically you're doing LangChain models, agents, prompts, and an MCP adapter. So basically you go through here, all the same stuff we're doing before, get the API key. So we get a client, which is an MCP client, so you can put multiple servers in there if you wanted to. So if you've ever seen like half of the tools out there have a JSON file for all of the MCP servers, it looks strikingly like this. So you could go parse on one of those files and actually stick it in there that way. It's got a name, the command, the args, and the transport. We get the tools from the client. I'm printing out, if it's in debug mode, we print out what the tools are. We get an LLM, so we determine what the model is, and we initialize a chat model. That's how you do that. It's pretty simple, and temperature. We create a prompt. So this is a chat prompt template. So you create templates so that it does stuff like it's supposed to do. So there's the thing for human input, the thing for the agent scratchpad, which is where it's going to put the results from the agent stuff. When it ships stuff off, you create a tool calling agent and an executor using the agent, the tools, and the verbosity level. And then this is user input we're gathering like we always did. And then you write an A invoke, right? So every time you do that, you just invoke another thing on the agent executor. It manages all the stuff where I'm making sure I put all the information for the LLM back in. I'm asking it I'm telling what tools are there. I'm getting the request for tools. I'm running the tools. I'm getting the response. I'm putting them back in, right? All that magic that we had to do, there was a lot of code to put that in over and over and over and over again. It all just kind of does that on the background. Now, if there's a problem, right, it's a lot of magic, which is fantastic. So I kind of, so in the Python world, that would be the difference between not using LangChain is like Flask, using it's like Django, right? In the PHP world, it's like the difference between Symfony and, I'm gonna forget his, and what? Laravel, yeah. It's all basically the same thing. Laravel just makes it easier to do that same thing, right, that you had in Symfony. So LangChain can just make it super easy to do that. You don't have to understand all the pieces, although it's probably important to understand all the pieces because when it doesn't work, you don't know why it doesn't work. This was some of the problems that we had early on when we were doing AI stuff using LangChain. It's like, why is this, why did it parse this PDF wrong? And what we didn't realize is that behind the scenes, if the PDF is an image PDF, it'll then run its own internal OCR. Doesn't tell you. It just does it. Because you didn't configure any other way to parse OCR. It just does it itself with a library that is okay running locally. On your server, it's problematic because it's using all kinds of CPU and you've got an async application. So be careful of the magic that it can do. But if you're just like, I want to find an easy way to do this and make this available, it's a really good way to do something easy and make it available. And we can do, I don't normally have that much stuff on my desktop, but I'm in the middle of SOC 2, and those are screenshots. Thousands of screenshots. I love compliance. I gotta remember where this is. Projects, come on. Presentations, and this one is Agentic. All right, so I can make this bigger. Is that readable? That's a very long thing. Example one, let's just, doesn't matter. Example one, they all do basically the same thing, right? So right now it's coming up, it started the server, it's in a separate process, And it's just talking to it through standard in, standard out. What can you do? Actually, you don't have to spell it correctly. It figures that out. All right. So it knows that it can perform arithmetic operations and provide the current time, right? So that was just me saying, here are tools. This is what you are. Here are tools, right? And so now I've got an AI that thinks it does these things. This is what it does. This is all it knows about. If you ask the actual model that, it would say a lot of different things. But right now, it's going to tell you what it's told, right? So I haven't tried this. Add the current timestamp. And 9. I wonder if it can do that. But it didn't do it.
Just told you what it's doing.
Yeah, it didn't do it.
I got you, bro.
Yeah. But it will do that. In theory. Now, again, that was really slow. Like adding those numbers comes up really fast with an application, but I had to send it to a model who had to think about, oh, I've got these tools. I'm going to call these tools. You had to tell it to call the tools and to give it the response so that it could give you the answer. So again, it doesn't go that much faster. But one of the big differences is
Somebody had a question.
you can give it text and it can figure it out too. Yeah. Nope. Like for this one, I didn't want to have to figure out, like, I have an example out there. Like, you can get, it's super cheap. You can get like really cheap OpenAI models that, like, you can run 1 million calls and it'll cost you $1. So I just set up the example for OpenAI using GPT-4o mini, which is like, costs near nothing. It doesn't do much, but it costs near nothing. Yeah, so the advantages here is you can get input of like, give you the numbers in text, right? And it comes back with, oh yeah, well, that's 1. I'm going to say, I need the integer 1, so I'm going to send the integer 1. So the LLM is thinking through, okay, how do I solve for this? Oh, I need to pass it integers because the tool said these are integers, and it passed the right thing, got the value back.
So the addition is happening locally.
Yeah, actually, let me do it this way.
It's that negotiation between OpenAI and your machine.
All right, I'll turn this on so you can see all the stuff that goes on. Right, so this is like all that verbosity stuff we had in there. Right, so what is 1 plus 3? Right, and so there's the request it sent. Right, so, where is it? We're at 1 plus 3. It made an LLM request, right? There's the system message. Here's the tools. And then I asked it, what is 1 plus 3? Right, so it's got all the information to solve the problem in the content and my question. The LLM said, okay, I need to run a tool. My content is, I'm going to add 1 and 3. It called the tool, add numbers, and here's the arguments. So that's the response I got back from the LLM. Yeah?
So every time you ask a question, it needs to repeat that and like tell it what it is and tell it what it has access to and all that, and that's why. Okay.
Yeah, because the LLM doesn't have state. So every time you send the request, you've got to tell it what tools are available. So if you, and keeping that context limited is super helpful. Because sometimes the answer might be like, you tell it you have these types of tools, those types of tools, and those types of tools, and you don't give it all the information about all the tools. And let's say, oh, well, I need this type of tool, and you can give it the information about those tools. Because I mean, depending on your model and how much you want to spend, right, there are 2 million token context models out there, but they are slow and they are expensive. So, but it does have to have all the information to make the decision every single time. It doesn't have any memory. It may know stuff like historical stuff, which it may or may not be accurate. So if you need something, number 1 is accurate, or need something external, you probably don't want to rely on the LLM because it doesn't have any access to that. It's just, it's literally just a mathematical equation that gets run over and over and over and over and over again to get an answer. It doesn't have access to anything else or memory what you asked it before. So that's why, like on a chatbot, you have to keep sending it the history of what you've talked about so that it knows what you talked about before. So you keep adding on to the chat history, you just keep adding more and more and more and more. So if we keep going, you'll see that it keeps adding on. I don't know if it'll actually, I don't know what it'll say to this. but you'll see that all the history was in there when it sent it. At least it should have been. Or maybe I'm not telling it that. Should actually be a multiplication tool, but it's not available. So I said, yeah, I don't know. That's good. It said, I don't know, which is weird, especially for 4.0 mini, for it to actually admit that it doesn't know what it's doing.
What is 6.7? Hey.
13.
That's what I thought it was.
Right, 'cause it's like, well, all I do is this thing. If you ask me what that is, you must be asking me to add them together.
I know, that's why I was wondering.
But like I said, to do something that's simple, like you can see that like there's a vast difference in the amount of code between, like when I started doing this, you had to come up with a way to explain it and return this to me this way, and here's the things I need from it, and there was a lot of code having to be written, and it was very brittle. Yeah.
So if you put in, like, let's say you wrote a novel about like something stupid, like actually, like just a whole story, and then at the end or somewhere in the middle, you put a request in there, would it parse through the like unneeded information and then grab what's needed?
It probably won't, because it's also another problem with prompts, right? If you have a bunch of stuff it doesn't need and a little tiny thing that it does, it will get confused because it thinks it's all important because you gave it everything, so it must be important. Now, I don't know if it would do that. I can't give it that much input here through the user input. Actually,
That probably worked.
how much would a woodchuck chuck?
The age-old answer. Don't even correct the spelling. It's got it.
This is actually my test for AI as to how good it is how it responds to this.
Really?
Because it used to be like it would just come up with like, oh well, like woodchucks don't chuck wood, and that was it, right? Because they don't. They move grass. And then it was like, well, then they started being, well, based on the amount of earth that it can move, you can turn that into this many pieces, right?
And it started like, yeah.
Yeah, then it started reasoning about it, right? So like as it got better, it started reasoning about it. Or another one is like, why is the sky blue? Those are like the two things I would do. Why is the sky blue? And you could tell if it was like what type of thinking model it was, because the sky is blue because of the color of nitrogen, and nitrogen absorbs everything but blue, so it comes out as blue. But that's wood. Right. But he said I can't do this. 6 plus 3. Six
Yeah,
plus
a little bit.
3 all the time.
I think it's got those. Yeah. As for the woodchuck, the woodchuck that amount of wood. That guy's sense of humor, too.
Yeah. So it's instead of coming like I said, the promise of it, right, is that I didn't have to say, oh, well, they might give me letters, right? I might have to give the words as spelled 6 and 3, and and what if they have a misspelling, right? Like all that stuff, code I didn't have to write to get it to add 6 plus 3. But the trade-off is it takes it like half a second to add 6 and 3, and it costs me a quarter or whatever for all these interactions going back and forth. If I use a real model, it could cost more. Like actually, this is probably context is so small, it probably doesn't cost anything. But so the price on this probably isn't very high. The latency can be very high. And if you're trying to get it to solve complicated things and you have other expensive calls mixed in, it can get really pricey. Like I have calls that, like to process a single letter costs us about $250 right now. Every time we do a letter, AI cost is $250. Not including the QA part of it with the models grading this stuff. So.
How much would it cost a human to process the letter?
It costs a human, well, actually, I know that. So let's see, that is 6 times $12 for a human to process it. based on the information we got back from one of our customers.
Did you have a non-AI process in place, and how does the price compare to that?
A non-AI process. There is no non-AI. Non-AI process is a human.
Okay, got it.
Like I said, like to process the letter, it's like, okay, I need to find how, like I have to go look through the policy, this 100-page policy, and find all of the places that will validate that that this is not covered. And so it takes them about, like, well, if they cheat, it takes them about 5 minutes, but then they get it wrong 30% of the time. If they don't cheat, it can take them, for a simple one, 20 minutes, and for a complicated one, 2 hours. And we do it in between like 15 seconds and 4 minutes. And it's always right. It doesn't cheat. It doesn't like, oh yes, it's here, and they forgot that there's like this other thing there or whatever. And it will also say, I couldn't find any, which is different, because they're like, oh, they forgot to, oh, this one has this endorsement, which says it is covered. They would have got really mad if I would have denied their coverage. And so, but that's a difficult thing to get to do, to say, I don't know the answer because it's not in there. But the hope, right, is that a lot of the stuff that we do that is programmatic becomes agentic as it moves on, right? Once AIs can process things better, like I have one thing that processes, and I keep trying to turn it into an agent, but it's just not processing well enough that if you've ever seen the declarations page of an insurance document, which is the first page of the insurance document usually, there's a bunch of information on there that I need off of that document. And models don't reliably return the data. I have to find the forms and endorsements that are also part of your policy. I have to do regular expressions. I have to do OCR and then regular expressions, because that's more reliable than a model doing it all the time. Because which my hope is that that's changing, is because now if you've been listening to like the kind of like the evolving latest greatest is models that are spatially aware. The problem is that if you look at, it's basically columnar data, and sometimes the columns squeeze together, but it's still columnar, right? So a human can look at it and they understand spatially, right, that there is a column being formed here. There's a header, and then there's everything kind of goes down here, and then everything kind of goes down there. And because these two are together, they're not one word. It's just this column ran to that column. So as humans, we can figure that out. As regular expressions, most of the time, I can figure that out. But a model just can't do it. It doesn't understand the spatial stuff. So like you can see stuff that, oh, this continues on the next line. It's pretty obvious to a human that does that. It's not obvious to a model. So, but every time we get a new customer, I spend 4 or 5 hours writing regular expressions to be able to parse that stupid document.
Makes sense, 'cause I screwed up my taxes last year when I fed in a bunch of stuff to OpenAI.
That's a whole nother problem. What you need is the Hewitt-Jackson MCP server to actually go to some accounting system. But yeah, like that's how agentic works, like very, very simply. Now the other thing is you start, and you may see if you're using AI to code, right? It's like you have this tool that gives you an answer, which it does this tool, and it just keeps moving through complicated stuff, solving problems. Like I said, our stuff is pretty linear right now, so it's not advantageous for us to do that. But as you get more and more customers and their workflows change, there's the possibility of agentic may be better, because just like, oh, here's what you need to solve. It needs to end up with this. This is their requirement. And then, oh, here's the tools to go get that data. I'll just go use those tools, get the data, and write the letter, as opposed to having to create these flows as go get this data, then go here and get that data, which is what we have to do now. Yeah.
Since a lot of this logic in your project is in a black box, essentially, how do you demonstrate to the auditors that you are making the correct decisions?
So we actually have the AI tell us why it did what it did.
Okay.
So yeah, that's one of the things that we have. Like, it's not required. It makes our customers feel better. And at some point in insurance, I'm pretty certain some states are going to require observability and explainability of why did the AI make the decision that it made. So we're kind of Because internally we're like, that's dumb, why did it do that? And then we look at it like, it also helps us fix the prompts, right? Because you're like, why did it do that? And it tells you why it did it, and you're like, oh, I guess we should clarify that. So it's actually super helpful when you're going back and trying to find, when you find those edge cases over time, you have to fix that. That's the problem with agentic type stuff and model type stuff, is that there are so many edge cases. And that if you solve one edge case, you can break another one because you create confusion somewhere else, your prompt got too big. It's a whole thing.
Then, related, how do you set up testing on a model like this?
So,
because as you mentioned before, it can give you a different response to the same inputs multiple times.
the best way to do it is if you have something that is known and predictable. If you haven't trained a model, you can at least know that, well, when you get this input, you should have this output, or at least something similar to it. And you can either do some sort of like simple, like data science model scoring, of similarity scoring, or like it doesn't work for any of the stuff that we do because every letter is unique, because it's being denied for different reasons. It may have different policies from different states and different endorsements. And a different reason that it's being, right? Different items, different reasons. So we use LLM as a judge. So we have another model that grades our models. So we spend a lot of time working on our grading models, and those grading models help us tune the generation models. It's like 2 years ago when we started doing it, it was like all bleeding edge, but now it's all the observability stuff. Every observability platform out there has, so what they call it nowadays is they call that, evaluations, right? So if there are platforms out there called observability platforms where you can judge your prompts and responses, the responses from your prompts, and you create evaluations where those things go, you can evaluate locally, or you can evaluate it using LLM as a judge. Or ours are complicated enough that it's not just, we need to judge that the information in the letter was put in correctly because it actually creates the whole thing. So the generations by themselves aren't enough. We need to make sure that the formatting was correct when it got into the final document, because in states, they actually really care is bold, and like if it's bold in your policy, when you cite it for denial, it must also be bold or italicized and indented correctly. And, that's like the hardest thing we do, is we have to make sure that those actually match up to what they're supposed to be. But yeah, that's like what you're talking about right there. That's like the new boom. That's what, there's observability platforms out there. Everybody's talking about observability on LLMs. That's what they mean, is being able to siphon off your prompts and your responses and then grade them somehow. Which is, if you saw my talk, a year ago, it was all about that. Like, you got to figure out how to do this stuff. Now they actually have systems for it. So we're actually looking at, we have a whole system that we built to do this. We're like, oh, we've got all these feature requests we won't have to do if we can just move this into one of these platforms. Because it's kind of clunky, it works and it grades, and you can get grades like in a report. Once a day you can get a report on what yesterday looked like, but you can't see real time what's going on as you're doing grading. And and being able to alter the prompts, and now every customer wants their letters a little bit different. So the output for one is different from the output for another. So now you've got to change your grading based on what that customer wants, because this one wants a different tone than that one, and you have to make sure the tone is correct. And it's a whole thing. Yeah.
If you're trying to control costs, are you able to get feedback about how many levels of auth it's applying? And then can you put a constraint on that?
So if you're doing it manually, sure. If you're doing it through LangChain, they have a way to set maximums. I know that they have it. I didn't really get into it because, again, I don't use it. But I know that it is there, that you can set, you can only go this many levels deep or stuff like that. Didn't need to do that for this example because it's GPT-4o mini and it's adding numbers. So I wasn't super worried about it. But the tools, like I said, if LangChain has it built in, if you're doing it yourself, then you've just got to figure what that is and what you want, or because that can be difficult. It's like you stop it right before it's almost there. I guess same problem you had like early on with like a lot of the coding stuff, because they would like really throttle you. Like, oh, you did 25 things in a row. Okay, we're done. You got to stop for a minute. And they stopped doing that because like nothing gets done with less than 25 interactions. But again, one of the ways to curb costs, right, is you can find models that make sense. Because I think any AI project, right, is how do you manage cost? Like for us, it's not that big a deal because we charge a lot. So our margins make up for it. So it costs like $250 for a generation. That's the cost, not how much engineering time. It doesn't really take into consideration the infrastructure, all that kind of stuff, but just the AI stuff there. For us, $250 is fine. For other people, that would just break their bank because they don't get to charge $15 a request. So that's a huge thing, and monitoring and managing it. So it's one of the other things about observability is monitoring cost. Is how much is this costing me, and which customers are costing me more money, and what parts of, which prompts are costing more money, how can I tune those prompts, how can I try different models? Because we're constantly looking for fast, we're not so much working for cheaper at this point, thank goodness, but we're always looking for faster, more accuracy. So anytime, like, guess what, we got 2 new models came out yesterday and today, so now we've got to run a bunch of tests, which are going to cost us a bunch of money. Probably spend like $1,000 this week just testing, is 5.1 better than 5? Is 3 better than 2.5? Because
Were they better?
oh, we haven't done it yet. Like just like I think 5.1 or 5.1 was released on API yesterday. We've got other work to do. But that'll be something that the engineers do. Like when they're like, I just want to do it. They'll just change it up, run a bunch of tests, and see if it's any better. Because they're fortunately. The guys on my team are super focused on delivering the best product possible. So they're like, I want to see, is it better? It's like, oh, Gemini does this really good, but it really screws this up like 10% of the time. Can I get rid of that 10%? And based on the tracking from 2.5 to 3 is just like leaps and bounds better. And we have a bunch of credits for for Google, so I'm hoping it's really good. That'll
Google Founder Program or whatever.
I don't remember what it is, but it's some Google AI. It's just AI credits.
Yeah, because I applied for that. They told me go take a hike.
It probably has to do with funding level and annual revenue.
They did, which I was like, I'm bootstrapping this.
Yeah.
Later.
And we'd also gone through other, like we'd burned through all of their other, like sometimes you have to spend money to get money.
Sure.
Like we had to burn through their other credits to get the next. AWS is the same way, right? I'll give you 5K. Okay, 5K is done. All right, you can get 10K. 10K is gone. All right, you get 25K.
Yeah.
Any other questions? All right, well, appreciate it. And you may or may not care, but the example code is, I just pushed it up earlier today. No, not from start. Sorry, I'll go back there. I took it away. I was trying to make it bigger, and I did terrible things. There you go.
It was easy to find just Googling U plus GitHub.
Yeah.
That's another way. Better ask the LLM. Yeah, so totally off topic-ish, but 10 years from now, like because Cloudflare went down and everybody's freaking out, 10 years from now when ChatGPT goes down, are like planes gonna fall?
Not 10 years from now, like
Right now,
once every 3 weeks when it goes down.
Yeah.
Like everyone, like Claude goes down constantly.
Yeah.
So no, they do go down, and it is problematic because
Is there like hybrid solutions people are trying to think of like falling back to other models?
no, there's
or
not.
It just turn the switch off.
Because prompts are tuned for the model, right? So it's like, oh, we're going to do this with 5.1 from, I think, right, we have some stuff that's still on 4.1. So if you want to test 4.1 against 5.1, the prompts have to be completely different because there's new best practice guidelines for how you write a prompt for 5, right? As versus 4 versus 5.1 versus Gemini. So you can't like, because I was like, oh yes, we'll just use all these different partners. Now, the difference with that is if the model's old enough, right? So it's not the latest OpenAI model, you can run it on OpenAI and Microsoft. So if OpenAI is down, you can then go over to Microsoft as long as you're running the same versions. But nobody else, there's no, like you can't just go from provider to provider like, oh, I've got like this provider here, and if they're down, then this one shows up because they're just doing reverse proxy. Yeah.
I've seen some people on YouTube like make these ridiculously powerful computers and host their own. Would that be a solution maybe to some of these like, oh, what if OpenAI goes down and I'm running a smaller business, like sort of thing?
So if OpenAI goes down, you cannot run OpenAI or something that performs as well, at least in my experience, OpenAI on something that a small business could afford. Like the GPUs necessary to run that are ridiculously expensive. And the power and the cooling, it's like running, to run one model is like running, I don't know, like 10 cryptocurrency farmers, right? Like it's gonna be 100 degrees wherever it is because you can't cool it down fast enough. Like we use the external services because there's no way we could afford to get what we get, even if we trained it. The difficulty, like our stuff is difficult because fine tuning is really hard because there are no right answers. Like I can't say if I give you this question, then this is the answer. Well, if I give you this question and these are the circumstances, right? So it's very difficult to get it to a thing where it can tune and do well. We have the same problem with examples in our prompting. We're running into a problem where we're going into different types of insurance, which is going to become problematic eventually because we used a different kind of insurance as the example, so it would never quote the wrong thing. When we actually used examples for insurance that we did use, it'd be like, oh, you've already got the answer. Like, no. That's not the answer this time. That was the answer for this particular policy. It's a different answer for that policy. We couldn't figure out why 30% of the time it was doing it wrong. It's because 70% of the time it's the same policy combination. But 30% of the time it's not, but it would still quote the other one because that was in the example in the prompt of telling it how to answer. It's like, oh, you gave me the answer, right? So it doesn't figure it out if it's got an example already. So if you do a fine tuning and you give it the answer, it says, oh yes, that's the answer. That becomes problematic. Yeah?
Related, have you forecasted at what revenue point would it make sense to have your own LLM?
It doesn't. Like the companies that are doing this are losing money, right? And my assumption is that they're all banking all of them, right? Because you hear like the bubble's going to burst because they're losing so much money so fast, making it accessible. Is I think they're all banking on either a massive model change or some sort of hardware change where it just becomes feasible. Yeah.
Just a comment there. So right now, LLM usage is being subsidized by VC money.
Right.
So we're getting that for free because the VCs are paying for it. Eventually, they'll want their money back, and then prices will go up, and then maybe we'll make something for them.
Right. Or prices don't go up, and they find like I believe that they're like everybody's betting that one of these people are going to make the breakthrough, which is why everybody's making their own hardware now, right? And they're all bringing in these super genius people to come up with the next way of doing it. So LLMs are really good at what they do, but they're very costly, right? But there's ways to make it easier, right? So quantizing is a way where you can get pretty good results. Although, like I can run on my laptop, I can run a quantized version of a gigantic model, so it's not as precise, but it's still basically doing the same thing. So I think everybody's betting on that there will be this some discovery that makes it to where they can still give it for the price that they're giving it and make money, because scale isn't going to matter. Right? Because a lot of times, like once we get to a certain scale, right, then we've got it where you're just building more data centers and spending more money on GPUs.
Well, there's like two tracks of research. There's making the models smarter, and making them more useful with fewer tokens and less electricity, but also now making them smaller. To make them smaller and try not to make them too much dumber.
Right.
Now, reduce tokens faster and also use less electricity. It's all about the amount of usable output for joules and power and
Right.
electricity.
But to answer your question, it's not so much an economic thing, it's an accuracy thing, right? Because right now, we are 90% accurate, and we are like 80% precision. So we answer the question we give them the right answer, and we give it 90% of the time, and we give them the way that they want it 80% of the time, which is 40% better than humans. Right? So people are good with it, except for our longest customers. Now we are the standard. Right? And they're like, well, hey, here's these letters, here's this 10%. Like, why are 10% not right? And we're like, a year ago, you were giving us, this is a perfect letter, and it was completely wrong. But the bar changes. And so there's a point that's coming that we know is coming where we're going to have to find a way to fine tune. And fine tuning is hard for what we do to get the right examples. Because actually, like you ask 3 people in the same company, what's a good letter? And you'll get 3 different answers. But we've been doing it long enough now that we have a pretty good idea. And so giving it enough data to be able to do it, it's going to be, we're going to have to synthesize data, and we're going to have to synthesize good data. So it's a large endeavor, so that's why we haven't done it. But at some point, right, we're going to have to get past where we are. The models, unfortunately, right, every 6 months, the models have another leap, and they just get better. Right? The accuracy gets better, it gets faster. Every 6 months, the product just keeps getting better and better without us having to do a lot, without us having to go into fine tuning or having to use our own model. But to reduce hallucinations, fine tuning is going to help with that. And then there's also the possibility that it actually knows information about insurance, but it's not necessarily accurate. Right? So just like kind of common information of like, well, what is coverage A, right? And coverage A is the home. Coverage B, other structures. Coverage C, things inside the home that are not part of the structure or another structure. And it starts to make its own decisions about what is coverage A, what is coverage B, based on all the knowledge that it had sucking in information from everywhere, which isn't accurate. So starting with a foundation model might be the best thing for us, where like I have some idea of what certain things are. I don't have opinions. I just have a lot of facts, and then train from there. So that's kind of like the fine-tune existing models, and then start with a foundation model and train from that is like the third step, which means we have to run it, right? Running is expensive. Now, fortunately for us, we don't get a lot of requests, right? It's like that's the beauty of being B2B, is it is low volume, high transaction price, as opposed to consumer, which is low price, high volume. So in our case, it could make sense. It doesn't, I mean, right now it doesn't make sense, but there may be a point where it makes sense, where as we're getting competitors and we've got to be better, right? If someone makes that leap and decides that they're able to prove that they can be more accurate than we are, then we've got to find a way to get more accurate. But it's just not there right now. Any other questions?
Sweet. Let me just do some. Can I get the microphone real quick?
Yeah. Hopefully it was recording because it was pointing that way.
Yeah. I know I just recorded something and some guy it was just like rubbing up against the thing the whole time. It ruined the audio, yeah. Thanks again, Adam. That was an awesome talk. So yeah, round of applause for this beast of a speaker. I love it. Yeah, that was an awesome talk. I have some questions for you, by the way, because you were talking about AWS MCPs, and I got very lost because it seemed like they have an MCP for every single service they have. And I was just like, I'm going about this the wrong way. So maybe I was looking at the wrong MCP. So I'll talk to you about that after. Just a couple things. So again, December 3rd, we're not meeting in the middle of December. So December 3rd, we're here. We'll have a speaker from Apple. That'll be awesome. We are looking for a speaker for January. If you do want to do a talk or you have something you would want to hear about, feel free to, either email me, or we have a Discord as well. Cody here has been moderating it very well. All the bots coming in, trying to get people to send Bitcoin to each other or whatever, and he's been banning them. So high five, Cody. Also, him recording, which I appreciate you, Cody. You rock. Best co-organizer ever. And yeah, again, thanks to Corporate Co-working, and we'll see you guys next month.